Hi, this video is about Avogadro's number and the mole. We're going to be converting between moles and atoms and molecules and grams. So you're going to need a calculator for this video. You're going to need a periodic table and something to write with and on. All right, so first of all, Avogadro's number, we were introduced to it back on Mole Day in October. It has a symbol capital N with a capital A as a subscript. It is a really huge number. It's 6.022 times 10 to the 23rd. It's known sometimes as the chemist's dozen. 1 mole of anything is 6.022 times 10 to the 23rd items. All right, we're going to learn how to convert atoms or molecules to moles and then to also go backwards. Avogadro's number is going to be our conversion factor. So 1 mole is 6.022 times 10 to the 23rd. So let's go ahead and start practicing. So follow along and write this down with me. We have 0.45 moles of hydrogen gas. And if we remember, hydrogen is diatomic. It's really important that you write down the number, the unit. The units will really help you, and then identify what it is. In this case, it's hydrogen. And they would like to know how many molecules there are. Well, molecules are tiny, so there's going to be a lot. So 1 mole, we're going to put the mole down here in the denominator so that it will cancel with the moles that we started with. This is like in the numerator. What you start with, it's like moles, and that's in the numerator. So 1 mole goes down here, and a mole is Avogadro's number of molecules. All right, and then you're going to have to use your calculator, and I would go ahead and practice with your calculator now to make sure that you are using your scientific notation correctly with your calculator. Again, I like to use the EE button, the engineering exponent button, but you can use whatever method you like, but make sure you get the right answer. And the right answer to this, to 2 significant digits, is 2.7 times 10 to the 23rd hydrogen molecules. That's a lot. That's a big number. But remember, molecules are really small. So this answer makes sense. Now notice what happened. We started with moles and we multiplied by Avogadro's number. Moles and we multiplied by Avogadro's number to give us molecules. All right, now we can go the opposite way. We could start with molecules and go back to moles. So in this case, we started with 3.075 times 10 to the 25th molecules of oxygen gas. Another diatomic molecule. All right, this time, see the molecules is in our numerator here. So we're going to have to put molecules down here so that the units will cancel. And we want moles, so we're going to put moles up here. 1 mole, the 1 goes with mole, and Avogadro's number goes with the molecules. All right, here what we're doing is we're dividing by Avogadro's number. So it's going to be 3.075 times 10 to the 25th divided by 6.022 times 10 to the 23rd molecules. I suggest doing it on your calculator, making sure you're using it the right way. And when I calculated this, I came up with 51.06 moles. So notice what happened here. That's moles of oxygen. Notice what happened here. We started with molecules. We wanted to go to moles, so this time we divided by Avogadro's number. All right, this one's a little more tricky. We would like to know the number of oxygen atoms, and we have sulfuric acid. All right, so we have moles, and we have moles of sulfuric acid. And just to keep us fresh on our acid naming, that's H2SO4. Well, we have moles. We know we're going to want to eventually get to oxygen atoms, but the first thing we're going to have to do is say that in 1 mole of sulfuric acid, how many molecules do we have? You guessed it, Avogadro's number. Okay. Now, if you notice, the moles cancel. See, we started with moles and we multiplied by Avogadro's number, and now we have that many molecules of sulfuric acid. But we haven't answered the question. They've asked us about the number of oxygen atoms. Well, in a molecule of sulfuric acid, we have 4 oxygen atoms. I don't want that to look like a 0. So we're going to multiply this by 4. So we converted the moles to molecules by multiplying by Avogadro's number. Now you have molecules of sulfuric acid, but to talk about the oxygen atoms, you just multiply by 4. Okay, so when you do all of that, what you come up with is 1.81 times 10 to the 24th oxygen atoms. So there's just kind of one extra step on there. Within a molecule of sulfuric acid, we have 4 oxygen atoms. Okay, well, a mole of copper atoms, let's think about that. It has a mass of 63.55 grams. All right, notice our unit is grams. The mass of a single atom of an element, which we find on the periodic table, is in AMU, atomic mass units, and that's what we've been using to calculate formula weight. But now we're going to start talking about a mole of atoms, not just one atom, but Avogadro's number of atoms, and now we're talking about a mass in grams for 1 mole of that element. Numerically, that formula weight that we calculated is equal to the molar mass. When you see this word molar, that really means in 1 mole. So what's the mass of a mole of copper? It's 63.55 grams per 1 mole. It's called the molar mass. Okay, so the molar mass of sulfur, you would just go ahead and look on the periodic table, and it's 32.07 grams per mole. Make sure you know the unit of molar mass, grams per mole. The molar mass of sodium hydroxide, NaOH, if we take 1 sodium, 1 oxygen, and 1 hydrogen, we come up with a molar mass of 40 grams per mole. All right, well, this is going to be useful. We're going to be able to use molar mass to convert between moles and now grams. So, if we have grams, we can use molar mass to get to moles, and if we have moles, we can use molar mass to get to grams. And we're going to use that same process we've been using with our units to help us cancel, and let your units help you out when you do this. Okay, how many moles of helium are in 6.46 grams of helium? So always start with what's given. And we don't want grams, we want moles. And in 1 mole of helium, there is 4.00 grams. I got this number from the periodic table. So sometimes when you go back and review your notes, you may wonder, where did that number come from? That is the molar mass of helium. All right, and so what we get when we do that for moles of helium is we get 1.62 moles of helium. A mole is 4 grams. We have a little more than 4 grams. We have 1.62 moles of helium. All right, now we can go the other way. We can start with moles and go to grams. So we have this many moles of zinc and we want grams. We start with moles, we want grams. So we're going to multiply by the molar mass of zinc. So you can look on the periodic table and it's 65.38 grams per mole. And what that ends up being is 23.3 grams of zinc. Now notice what's happened. If you start with moles and you want to go to grams, you multiply by the molar mass. If you start with grams, like we did in the last slide, and you want moles, you divide by the molar mass. Okay, now we have got 16.3 grams of sulfur, and we want to know atoms. We don't have a direct way to go from grams to atoms. There's not like one step. We can't put grams down here and atoms on the top. But what we can do is we can convert grams to moles. So let's go ahead and do that. A mole of sulfur is 32.06 grams. Now the grams of sulfur have canceled. We have moles of sulfur, and they were like atoms, and that means we need to use Avogadro's number. So this problem is combining, it's a two-step problem, and it's combining the Avogadro's number as a conversion factor and molar mass as a conversion factor. If you let your units help you out, it's really not too bad. All right, so when we do all of this, how many atoms? Let's see, it's, yes, it is 3.01 times 10 to the 23rd sulfur atoms. Okay, so that was combining the two things. Alrighty, and let's just try one more. How many moles of sulfur dioxide, that's SO2, are present in 6.07 grams of sulfur dioxide? Alright, we don't want grams, we want moles, and we are going to have to calculate the molar mass of sulfur dioxide. It's calculated exactly the same as formula weight. And so we're going to do 32.06 for the sulfur, and we're going to do 16. We're going to multiply that by 2 for our oxygen, and we will get our molar mass of sulfur dioxide, and all of that equals 64.07. Now, again, we calculated it just like formula weight, but this time our unit we're going to use is grams per 1 mole. That's our molar mass of sulfur dioxide. And that 64.07 goes with the grams, so it's going to go down here in the denominator. And so like we learned before, if you have a mass, if you have grams, you're going to divide by the molar mass to get moles. And so when we do that, we wind up getting 0.0947 moles of sulfur dioxide. These problems take just some practice, and it should become like second nature to you. It'll be a little tricky at first, but the more we practice, the better we'll get. And I would like you guys to try this problem. This is a challenging problem, and we are looking for hydrogen atoms in 72.5 grams of rubbing alcohol. Give this problem your best shot. Bring it to class tomorrow, and we'll start with this problem in class. Have a good night.